find the area of a parallelogram, you want to do base times height. The base is how long the base is, or the bottom of the shape is. This is 3 blocks long because it takes up 3 full spaces or lines. Not the boxes around it, but the actual lines. The height is if I dropped a penny off the top down to the ground, how far it would fall. This has a drop of 3, so a height of 3, and the base is also 3. 3 times 3 is 9. The area of this first parallelogram would be 9 units squared. The second parallelogram has a base on the side. I can almost turn this in my head and think of the base now as this bottom. 1, 2, 3, 4 lengths long. So I consider this the base, and the height is always perpendicular. So we can think of either dropping a penny down the side or looking at a line that's perpendicular to my base. And this is 2. 4 times 2 is 8. This parallelogram has area 8 units. The third parallelogram has a base of 2 and a height of 1, 2, 3, 4, 5. So it has an area of 10 units squared. The area for all parallelograms is also always base times height equals area. If I were to look at a rhombus, which is also a parallelogram, I might find that my bases and heights are not perpendicular. They're not using the grid lines. To find the area of rhombuses, I can think of this as 2 triangles with a base of 1, 2, 3, 4, and a height of 1, 2, 3. 4 times 3 is 12. Divided by 2 tells me this top triangle is 6 and the bottom triangle is 6. Some of you realize I can do 4 times 3, and that would be my answer, 12, because dividing by 2 and doubling means that it's just the same as 3 times 4. So the area of this rhombus is 12. You could also make a box around the whole thing, 4 times 6, because this length would be 6. Divide that in half, you'd also get 12 units squared. This one I'd go across the middle. 1, 2, 3, 4, 5, 6, 7, 8 times 2 is 16. Divided by 2 and doubled gives me also 16 units squared. So for a rhombus, I want to think about it as 2 triangles. I can find the area of each triangle and then put them together to make the area of a rhombus. The same goes for kite. A kite is also 2 triangles. It's best to use the line of symmetry, the line going right down the center of the kite. Even if the kite is facing in this direction, you want to use the line of symmetry. That gives you 2 of the same triangles. Here this base is 2, and the height of this triangle is 3. I can imagine just this obtuse triangle here, which is 2 by 3. 2 times 3 is 6. Divided by 2 is 3 for this side and 3 for this side, for a total area of 6 units squared. That same idea can happen 2 times 3. Divided by 2 times 2 is the same as just 2 times 3. This one, 1, 2, 3, 4, 5, 6, 7. Height of 2. 7 times 2 is 14. So I've got 7 on each side, or 14 units squared altogether. The trapezoid can be done in a couple of ways. One is to break it up into 3 shapes, or 2 depending on what kind of trapezoid it is. A rectangle and 2 triangles, or maybe a rectangle and 1 triangle. I can find the area of each of these. This would be 6. 4 times 2 divided by 2 is 4. 2 times 2 divided by 2 is 2. The total area is 12 units squared. I could also think about it as finding an average base. Here's another trapezoid. It has a base of 1, 2, 3, 4, 5, 6, 7 if I add both of the bases together. And I want to find an average base. So 2 plus 5 is 7, divided by 2 is 3.5. My average base is 3.5 long. This triangle here could fit into the area of this green, not this trapezoid, could fit into that green rectangle by moving this outside part in here and this outside part in here. It's a 3.5 long by 2 high, So the area of this shape is 7.